Thank you. So the previous session was a fantastic outline of some of the challenges out to 2050 and the opportunities, and indeed the transformative changes that are needed in the energy system. This session is focusing again on hydrogen, but a lot more on what needs to happen now in order to get to that 2050 view. So it's very much around the hydrogen roadmap that is being developed both in Australia and in Germany. So I won't take up any more time, except to say that we are aware that the Architect BDI delegation has to leave at 2:15 sharp. So if this session runs beyond that, which I think it was scheduled to run for an hour and a half, so it may well, they will unfortunately have to leave at that time, but we will continue. It's been wonderful to have their involvement. So let me introduce to you Alison Reeve, who is chairing the session for us, and also one of the leads of the Hydrogen Strategy Task Force work. Thank you all.
Thank you, Rebecca. So the way we're going to run this session today, you're going to have a chance to hear both from me and from Falk Böhmke from the German government about our respective hydrogen strategies. And then I'm going to ask our panellists to each make some short opening remarks, and I'm going to be quite brutal with them about being short, because our job as the panel that comes directly after lunch is to keep everybody awake. And so that job rests partly with us as panellists to be as interesting and entertaining as we can, but then in the second half it is going to rest with you, the audience, to ask some questions that are provocative and that help engender a very lively and discussion amongst the great variety of people that we have here. Okay, so look at that, it works. I'm from the government. I'm not used to the IT ever working properly. It just doesn't happen. So I wanted to give a short update on Australia's National Hydrogen Strategy, and I thought I might start with a bit of recent history, because hydrogen has got, as everyone knows, it goes through these waves of interest and then it sort of dies away again. We had one in the early 2000s, there was one in the 70s, there was one in the 1940s, there was one, you know, in the early 1900s. But in this most recent one, where I like to think of it starting in Australia was with the CSIRO Low Emissions Technology Roadmap, which was released in 2017. And this roadmap kind of, it really highlighted for us the fact that we had this kind of stranded renewable energy asset and potentially a way to move it somewhere else. And this was before Japan's basic hydrogen strategy. It was before the Hydrogen Council report. And this was, I think, the first inkling that we got that, hey, there's something here that is perhaps bigger than we have thought of it in the recent past. And so that was kind of rapidly followed by lots of different reports. So the International Energy Agency started to look at Australia as a potential case study. We had the Hydrogen Council report. We started working closely with Germany and the EU through Mission Innovation to talk about research and development collaborations. The World Energy Council published a report last year, and here, see Christopher's here, that I think called Australia the giant, or the potential giant of hydrogen synthetic fuels. CSIRO put out a technology roadmap last year. And then things accelerated a little bit more with the chief scientist giving a briefing to our, what we call our Energy Council. So these are the energy ministers from the state governments and the federal government. And that's, you may have picked this up in the last 2 days, but in Australia, energy is actually a matter that's governed by the states. But in order to make it nationally consistent, we have this thing called the Energy Council, where all of those ministers get together and make or don't make decisions. We also had a report that came out last year that was our first attempt to quantify what the GDP and jobs impact of a potential export industry around hydrogen might be. Now, that was a first go based on not very much data. It's a bit like that. But I think that combined with the chief scientist speaking to the energy ministers and also the interest that was coming from international bodies and from Japanese consortia that were coming here to set up and so on, really pushed the ministers forward to say, okay, I think we need to have a national strategy on this. And so that's what we've been working on this year. And really, this was kind of the vision statement that they gave us, a development of a clean, innovative, competitive hydrogen industry that benefits all Australians and is a major global player by 2030. So, you know, no pressure. But for a little more detail, these are the things that they asked us to look at. So we've sort of got 5 potential value streams to look at. Exports is the one, and there's been a lot of talk about that here today. But we also are looking at the role that it can play in our gas networks, the role it can play in transport here, the interaction between hydrogen production and electricity systems, and also potential for industrial users to use hydrogen as well. And then we have a whole lot of other issues that kind of cut across all of these. And so those are things like production, but then also kind of the underpinning things that make an industry work, whether you have standards, whether, as I think someone mentioned in the last panel, the community accepts what you're doing, what the environmental impacts are, what R&D do you need, how do you finance this, how do you govern it, which minister is going to be responsible for which bit, and all of this nitty-gritty detail. And what we're finding when we go through this process is that this is a bit of a balancing act in terms of what we put into our strategy. There is still quite a bit of uncertainty about exactly when and where and how big a global hydrogen market is going to be. Now, I feel a little less uncertain after this week, to be honest, because I've heard very much from a lot of the people in the German delegation that they are very much interested in partnering with Australia as a supply country. So I feel like the uncertainties come down a little bit, which is nice. But we also feel that there's a sense of urgency, that there's a need to grasp this opportunity before it gets away. Australia is definitely a country that has a high production potential, and we will have a report coming out next week that attempts to put some numbers on exactly how high that production potential is and where it's located. Coming back to the discussion in the earlier panel about whether or not Australia is an empty country, the way we did that report was we started with the renewable resource, and then we took away all the bits of land that you can't use because people live on them, or there's a mining lease, or there's a national park, and so on. And then we added another layer of whether there's water available in those sites. And when you do that, that really brings it right back to quite what look like small areas of land. But what I want you to remember when you look at this report when it comes out next week is Australia is a huge country. You probably noticed this when you flew here. You probably felt like you were spending half the journey flying over Australia. So even when we take out all of those constraining factors and put in other constraints like whether there's infrastructure available and how close are people to ports and so on, there is still a huge production potential there. The thing is that if you want to build to take advantage of that production potential, you need customers. So that is the thing that feels still a little bit uncertain, is where and when does that demand come? The other thing, of course, is that business always tells us they want national consistency, they want everything the same in every state. Thing is, most of the regulatory powers that will govern the development of this industry sit with states and territories, and they all have slightly different systems. So we're doing what we can to make it as consistent as we can, but we need to balance that most of the powers sit with the states, and the federal government mostly can't tell them what to do. And then, of course, the other thing that's been a bit interesting is that this was commissioned by energy ministers, but a lot of the things that we've looked at are not within their remit. So if we are talking about skills or R&D or innovation, that doesn't really sit neatly with them, neither does transport. Neither does export controls and trade policy and so on. So the other thing that we have to unpick is how do you take a product that's been commissioned by energy ministers and turn it into whole of government action? So the way through, I've made this all sound very hard, but we think there's a way through here. And this is that we think we have an understanding of the potential opportunity. We think there's a number of future scenarios that could emerge. And, just as part of managing that risk, we are also looking at scenarios where hydrogen doesn't do very well, where perhaps there's some other technology, maybe electrification is larger. We're sort of trying to figure out what those scenarios might be. And then we think that there's a way to take early actions that allow all of those scenarios to either emerge or not emerge, and at the same time to look for indicators that allow us to see how and when we should change what we're doing to shape Australia's hydrogen journey towards the scenario that looks like it will work out best for us. And so we know there are a number of early actions that we can take next year, and the year after and the year after that. A lot of those are just things that in the current regulatory environment that don't work out for hydrogen. So a really good example, a lot of Australian gas companies are interested in putting hydrogen into the gas networks. The definition of gas in the Australian National Gas Law is a naturally or synthetically occurring hydrocarbon. So one of the things we need to do is to think about how do we tweak that definition so that you can have other gases in there that aren't naturally or synthetically occurring hydrocarbons. So there's lots of little things like that we can do. There's also lots of things where we think there's an opportunity to unlock value regardless of whether hydrogen ends up being a massive part of our economy or not. And then the fourth part of this approach is that we need to keep looping back to this strategy. My team were joking the other day that we're going to have to work on this for 10 years, aren't we? You were lying to us, Alison. You said it would all be over at the end of the year. And I'm like, yeah, no, sorry. We're locked into this thing of needing to come back and checking whether it's working and checking, how the future is evolving. So just very quickly, the 4 scenarios that we've been exploring. These are basically just around, we of course have a kind of a reference scenario, business as usual one. We have a scenario where it's called hydrogen loses to electrification there. I don't think it's actually losing, it's more that electrification takes a larger role. There's one which is kind of a hydrogen triumphs one, and then there's this sort of targeted one, which is where hydrogen sort of gets into the high value uses, but doesn't necessarily do every single possible thing that you could do with hydrogen. So they're kind of the ones that we're exploring at the moment. And out of that, what we think are some of the areas for action are how we get local production capacity and local demand. One of the things that we've really come to understand this year is that even if we're an exporting country, the need for local demand doesn't go away because that is part of hedging your risk as an exporter. The more off-takers you have, the easier it is to spread your risk around, and if some of those are local versus overseas, that helps. We, as I said, need to look at the regulatory environment. We see international engagement as being really key to this. We feel that there's a need to put together agreements with with other countries who are both potential markets and also potential sources of technology. We also, Australia is kind of a medium-sized country and economy. We do best in a world where there's multilateral trade and where trade is open and where, that there aren't barriers. And so what we don't want to see is barriers to trade emerging in this new industry because that will hold us back. We also have to think about attracting investment, so making, the investment environment good for international capital that wants to come here. The skills and training thing is actually, it's one of those things which I think will end up being bigger than it looks. So that's talking about not just new skills that are needed, but also how you transition people in existing industries. So, for example, someone who is a gas fitter now, if they need to start working on a gas network that's got hydrogen in it in 5 years, do they need to learn a new competency? Do they need new practices? That sort of thing. And then the innovation and R&D side, which Daniel covered in the earlier session, is also very important. And again, looping back to the fact that we have to try and keep this as nationally coordinated as we can so that the states aren't competing with each other but rather are cooperating so that we can actually build things faster and better. I just was going to put something up a little bit around this momentum as well. I just did a bit of a look back on what we'd been spending on hydrogen as the federal government. And back in 2015, we pretty much funded a bit of R&D, and that was it. It wasn't very much. 1.27 million. So if you're in the room and you got one of those grants, there probably weren't that many of them. And then in 2016, we did a bit of R&D and we did a feasibility study for the hydrogen supply chain project in the Latrobe Valley. The year after that, I think we did a bit more R&D, and I think CSIRO put their Hydrogen Future Science platform together. But then it was the year after that stuff really started to take off. We funded the Hydrogen Supply Chain Project, which is the joint project with Japan. We funded the Future Fuels CRC, which is a very large R&D and industry project to look at the future of fuels in pipelines, so very much including hydrogen. There was, of course, a bit of R&D, and we also did our first trial of hydrogen into gas networks. And then this year to date, we've also funded 2 refuelling points, a microgrid, 2 more hydrogen in the gas network trials, and the HAZER project, which is a new technology that takes or makes hydrogen out of methane with only solid carbon as a remnant. So the momentum is really building in Australia. What we're really keen to make sure is that the strategy allows that momentum to keep going. So our next steps are our ministers in all the states and territories and the federal government are going to start looking at a draft this month. And we're anticipating that we're going to release the strategy in December. And then the hard work starts. Then we have to actually implement it. And I think that's sort of some of the theme of what we might talk about in the panel today is what comes once you've drawn the map. How do you take the first step? So that's it from me. I'm going to hand over to Falk to talk about the German strategy. And if anyone's got any questions of that, maybe hold them until we're doing the panel, and maybe the same with the German side as well.
Well, thank you very much, Alison. I will be much quicker. I could actually just say we do it kind of the same way as the Australians. And there is some truth in that, because when our new state secretary took office in February, one of his very first appointment was with Alison Reeve. And she brought along a person called Dr. Alan Finkel. And he explained to us that he is working on a national hydrogen strategy in Australia and what's behind it. And then the state secretary, after he met the two of you, said, I want something like that too. And basically, that's what we're doing now. We're drafting a national hydrogen strategy for Germany. With the same timeline, interestingly enough, we also want to finish until the end of this year. And it's obviously a little bit of a different approach because Australia is going to be a hydrogen producer, whereas we in Germany are most likely going to be a hydrogen importer. We also want to produce hydrogen just to learn about the technology and get the industrial base, and I think that's something that's very similar in Australia and in Germany, that we have a good industrial base already in the countries, and that we can build on when we have the new technology or the technology that is not really new, but it will be in a larger scale, and that we combine these two industrial bases of our countries to go forward. We had started, before we talked about a hydrogen strategy, we had started with a multi-stakeholder process called Gas 2030, because we wanted to find out what is going to happen to the gas infrastructure and to using gas in 2030, considering that we are trying to decarbonize our industry and our society. And there were already some proposals in that stakeholder process that were leading towards hydrogen, obviously. We then started a process which is hard to translate. Some call it living labs or regulatory sandboxes, where we dedicated quite a lot of money to projects that can show us how to realize the energy transition and how to get to our goals in 2030. And our minister announced the winners of the projects that were proposed, and it was 20 projects that got awarded, and 10 of them are actually about hydrogen. So you see the importance of this topic also in industry and also in the scientific debate. And now there are 100 million euros per year spent on these projects to actually see until 2023, to actually see what can come out of it and what regulatory environment they need, what are the technical improvements that we hopefully make. So we are building on these two processes, on the stakeholder process, Gas 2030, on the living labs, to actually make the hydrogen strategy out of that. So I can't tell you what's in it, because obviously it's still work in progress, and it will be published at the end of the year, but it will have the obvious, I would say, potential areas for using hydrogen in it, and that's the transport sector. We see it as a feedstock for synthetic fuels and basic chemicals. We see it as a fuel for low carbon manufacturing processes, for example, steel making. And in the long term, there could also be a place in the power sector, for example, for peak load power stations and things like that. So we can make use of our bilateral cooperation with Australia and the industrial opportunities that I already mentioned to actually bring that topic forward and learn, we both can learn from it and then see where we end up. In the end, we need a demand market. I mean, here we have the conditions, probably perfect conditions, to produce hydrogen out of with the use of renewable energy. So let's call it green hydrogen. And I expect that Germany, when we import hydrogen, we will only ask for green hydrogen, because we are doing it not because we like hydrogen or we like to change anything, but we want to decarbonize. And we need solutions for these sectors that we can't electrify. So we definitely won't electrify everything. You know, Germany is a very small country. We already have challenges in building new onshore wind farms. So there is a limit, there's a space limit, and there's also a technical limit in producing energy. We use about 2,500 terawatt hours of energy per year, and we're only producing 200 terawatt hours with renewable energy at the moment. And we can't scale that up by the factor of 10. So we need other solutions. Green hydrogen would be one of them. And that would create a demand. And then we will look at the market, at the world, who can offer us this product. And then at some point, we will also have to talk about what is green hydrogen, and is there a certification process or something like that that ensures that it is actually a carbon neutral energy carrier. So that is also something we're looking at in our hydrogen strategy, that we need international fora, that we need multilateral organizations that look into this certification process. And we can also start this by doing something bilaterally and looking into it, what is possible and what makes sense to drive the multilateral process. I will stop here, and I'm looking forward to your questions. Thank you very much.
Thanks very much, Falk. Our next speaker is Professor Robert Schlegel. He is the director of the Fritz Haber Institute of the Max Planck Society, and I understand he's also director of the Max Planck Institute for Chemical Conversion. I looked up his very illustrious career and saw, I'm not going to tell you all of the prizes that he's won because there's a lot of them. And it seems that he has also found time in that as well to be on the editorial board of some journals, and he's also a fellow of the Royal Society of Chemistry, as well as having exciting time to come out to Australia and contribute to many processes in Germany as well. So, Professor Schlegel, could I ask you to come up and give us some opening remarks, please?
Is that on? Now it's on. So good afternoon. I try to be short because I was said I will be crucified, so okay. I will first, this is the reason why I will, no, I have to go back. Circular economy of energy carriers, the word circular economy hasn't occurred in this whole debate so far, and that is essentially my short focus that I won't bring to you. I leave this first slide. I was told I should explain to you where the funding of energy research comes in Germany from, but by now you know this already, and I only have to say the lead in this is sitting here, so here is the lead in energy funding. So I skip all this. This was very nice, but not necessary. There are lots of sources of funding in Germany, I can tell you. This is more serious. Alexander von Humboldt, probably very well known, wrote in 1800, die Menschen haben die Macht, die Umwelt zu zerstören, und die Folgen könnten katastrophal sein. Humanity has the potential to destroy the environment, and the consequences can be catastrophic, in 1800. And he meant, indeed, what we see here. This is a measurement of the global temperature distribution from this year, earlier this year. And what I want to point out here is not the modeling consequences, but simply the perception problem. Because you see that the biggest changes, and look at the scale, is not by 1 degree or 1.5 degrees, it's by 10 degrees. These changes happen in areas where almost nobody lives. And so we do not recognize that. And the consequences of these changes are in time scales that are not perceptible by people who think in years or decades or political processes. Yet the consequences in the end will be felt by all of us. And so I want to mention here there is a so-called perception gap. That means we are talking here about fancy things that is very interesting, and the planet does something quite different. And there's a significant misconception between these two things. And maybe that is also a motivator that we should put into consideration when we think about what we do in hydrogen. So energy input, this is another point that has been raised several... No, I'm too fast. Has been raised several times. There's this big gap in policies that has been mentioned this morning, so I skipped the further details. But I want to remind you on these numbers, and this is energy consumption in Europe, not in Germany. And this is in megaton oil equivalents, and if you want to know what that is, then you multiply this thing by a number of 3, and then you know the number of supertankers that you need to transport that. So 3,000 supertankers a year, okay, that is what we're talking about. This is European energy consumption. And about 20% is Germany, roughly. And the core point that was being made also by the previous speaker is at the moment in Europe we generate these 211 megaton oil equivalents as renewables. And what is left until 2050 is this 1,200 megatons oil equivalent, and if we want to really reach this, then we need roughly 40 megaton oil equivalent growth of renewable energy capacity in Europe, and we do at the moment 10% of it. Okay, full stop, that's the message. And that leaves ample opportunity for everything what we discussed in the morning. And what I want to mention here is the scale of this thing is so big that when you think a supertanker every 2 days or every 3 days is equivalent to hundreds of chemical complexes. And they have to be understood, they have to be built, they have to be financed and operated. So what we can only say is we have not the luxury to think about elaborate, fancy new technologies. This has to be very robust and super big. And you want to do this as fast as possible. So what helps here is circular economy. A circle between fuel on the CO2 side on the one side and on hydrogen on the other side is very helpful to transport large amounts of energy. And that is not an invention of us. This is how Mother Nature does it. When you look in nature, you have 2 circles. One is a hydrogen circle, and the other one is a CO2 circle. And there are 4 enzymes, and they do this in every green leaf that you have in your environment. The 1 minute will not be enough, I can tell you already. What I want to allude to is, we discussed the blue part of this diagram this morning extensively. You take energy, you split water, you get hydrogen, you bring it to some place of consumption, and then you have a cycle in the oxygen you simply forget. That is, however, not very clever because transport of hydrogen in bulk quantities is and remains a big problem. So we need probably another carrier. This is bind on a carrier. It might be nitrogen, it might be CO2. I don't care about this. And then you have to have a small cycle on this. The interesting question that goes on top of it and that makes this thing a little bit systemically complicated is, why do you want to do hydrogen in the first place if you have an end use that is not necessarily bound to hydrogen? So this is maybe a good idea to take this yellow thing, what I call a refinery, and put CO2 in this and make a real fuel out of it, consume the fuel, collect the CO2, and then have a CO2 cycle of that. And then have two circles that you have to get. One makes hydrogen and the other one brings the hydrogen in a form that can be used. The big advantage of that is this is essentially no path dependence on distance because that is what we do today. We do not need a downstream infrastructure for that. We need a complete upstream infrastructure. And the last point that I want to show before I leave this, I'm crucified, I know. What do we do in practice? We have several technology options. This is renewable electricity, and we all talk about electrochemical water splitting, but there are other options. And I think these other options have not been put enough into consideration because when we think about a timescale of 10 to 15 years, by that time we have certainly also other possibilities that I have mentioned here. And then of course we generate first hydrogen. That is evidently clear that we need this. And then we need to transport this, and of course we can do this by liquefying it and transporting it as hydrogen. That is, in my view, the least useful option that we can do. This is very wasteful. It's a lot of technology in this, and we have many other options that come from chemistry. We can use metal hydrides, for example. That is also not my perfect solution because it's very inefficient in my view. And we have, of course, chemical energy conversion. That means we bind it on something in a molecular bond. We have lots of options. I have written here only 4 of them because they are all technologically existing. All these 4 options, they are written in these colorful things. You can build and buy in large scale. There is research useful and there's improvements possible, but for the first, say, 500 megatons of hydrogen, you can use these technologies that I have indicated here. It's there. You can buy these. Then, of course, you have to transport and store it around the world with ships, with pipelines, you don't care. Put the sunshine in the tank is the good word. We have seen this before. And then you can recuperate this. When you do the top 2 ones, then you have thermal recuperation. If you do this with chemical energy conversion, you have to reconvert that. That is also fine. And also those technologies are all existing. So we do not really need to say we have to invent lots of big things before we can do this. This is already here and there. And there's very little that prevents us from simply doing this. You have now alluded to very many maybe economical or political difficulties that are in this. The technological difficulties have not been discussed here. There are also technological difficulties. I wanted to show them to you, no time. I just mentioned one. The biggest problem that we still have and that is not very well solved is the global scaling of water splitting. There is still a problem. So the first, say, 500 gigawatts are maybe okay. But then it runs into a problem. So when you really build this worldwide, then you will see there are materials problems that are not sufficient. There are noble metals in these things. And then people say, alkaline electrolyzers have no noble metals in it. Yeah, but they have other problems because when you operate them intermittently, then you have a significant loss in stand time of the catalysts. And there are issues with this. That does not mean we cannot do this. And I do certainly not tell you we first have to do research before we start this. But the world did not start with iPhone 10. The world started with iPhone generation 1. And for generation 1, we are perfectly fine. We are probably even fine for generation 2. But we are not fine for generation 10. So and that is, I skip this again. But that I will have to show, and then I'm finishing. Mobility. This has been discussed over breaks several times. We have these 4 vectors. We can use ammonia. We can use LOHC, as I said. We can do fuel cells. And then, of course, we have this box down there where we use CO2. Then we can make synthesis gas or methanol. And then we have a huge box of possibilities that we can all use. And I do not quite understand why do we talk about electromobility, and that comes directly from a battery and the power plug. Why can't we use the thing what people call fuel processor and put a little bit of liquid fuel on the car and process it there? Of course, then you emit a little bit of CO2, but the efficiency of such a machine is on the order of 1 liter per 100 kilometer fuel. Where's the problem? And we can deal with this later. But that removes an enormous pressure that is sitting on the system, because when you have all this electrification that you want to do with the mobility cars and all these batteries and all the CO2 emission that comes from the new electrified cars, then you have to think very carefully, is this not also an option? And this option has to come anyway, because you have to bring the renewable energy from somewhere in the world to Germany or to Europe. And then why don't you drive with it? This is a very simple system. It's an easy solution. Chemistry can offer this very quickly, and I think that is not seriously enough in the debate that we have now. I make the anti because I don't want to be crucified from you. Thanks so much for your attention.
Thank you very much, Professor Schlegel. So our next speaker is Werner Priest from Siemens. He is responsible for business development of emerging technologies in Australia, and he looks like he's done a little bit of everything, a little bit of utilities, a bit of oil and gas, a bit of industry, a bit of metals and mining, a bit of power generation, a bit of renewables. So I'm really looking forward to his reflections on our theme today. So Werner, thank you.
Thank you, Alison. So I think we can all see that from the discussions today that there is an enormous opportunity for Australia as far as the export of renewables is concerned. But I think the elephant in the room is how do we get there? What's the pathway? And talking about elephants, if we're going to eat an elephant, we're going to eat it one bite at a time. So I'm going to talk a little bit about how we see a pathway to this potentially large export industry for Australia. So over here, you can see the Mackenzie's matrix, which I'm going to use to try and explain this. And I want to point in particular to remote area power supplies. I think that the focus for us here in Australia is to look at a market where you've not only got the supply, but the demand on the same site. And currently, our government subsidizes diesel into many of these remote communities, thousands of kilometers away, and their cost of energy is sitting in the region of about $500 to $650 a megawatt hour. So there is a big opportunity now to bring that cost down. We've got both the supply side and market in the same place, and 21 megawatt, 1 to 2 megawatt solutions would justify about 100 megawatt market of electrolyzers per year if we were delivering 20 projects, and there are hundreds of them around Australia, not only for remote communities, the indigenous communities, but also for mining. The other area that's of interest, where we can start to focus on, is re-electrification and energy services. This is taking curtailed energy, turning it into hydrogen, putting it into our gas network, but also providing that ballast or stability function within our grid, which is important as we take up more renewables. And this will all lead to a market, a sizable market in Australia, where I hope to see the large electrolyzer factories being built here on German technology, hopefully, Siemens technology, where we're churning about 100 megawatts to 200 megawatts of electrolyzers out into the market here in Australia. And that would justify the large automated factories that would bring the cost of these electrolyzers down by about 30 to 50% of where they are today. This would then lead, and we're seeing a few of these small export projects potentially now, where Attilio talked about his Port Lincoln project and ammonia potentially being exported out of that. But what it will lead to in time is a large industry applications and viable export industries. And this is the next big export opportunity for Australia that will create the new jobs around an industry that will create the growth needed as the world weans itself off fossil fuels in the future. This over here is a depiction of how we get there. We're seeing a number of projects, the Tonsley project by AGIG and Siemens that's going in now to 1.25 megawatt, ATCO in WA and Gemina in New South Wales They're small projects, they're very costly, and they need to be subsidized. And their subsidies are sitting at about $5 million a megawatt. As we start to move to the bigger projects, those subsidies will come down, and this is where ARENA is playing a very important role. And when we start to see the subsidies really coming down to almost zero, this is when these large export projects start to begin. But we need to note that we need to, as Australia, take a first mover advantage because we're in a competitive environment. And if we don't take that first mover advantage, we could lose that opportunity to others around the world that are developing their skills in this space. We see some gigawatt projects that are being talked about, and I think Andrew will talk about that in his session. The other area that's of interest, and we call this high flex, is we're seeing the marginal loss factors in our grid now. Too much energy coming in, the grid can't support it. AEMO is saying curtail. Enormous amounts of energy are being curtailed at the moment. Here's an opportunity to capture that energy, pump it into the gas grid, and Siemens have got the gas turbines that can run on 100% hydrogen, and more developments are happening in that space. But we've also got the condensers on these gas turbines that can run decoupled and provide that stability like a flywheel in our energy system, providing the inertia that we require and fault currents that we require. So that's my piece. Thank you.
Warner, thank you very much. I'd now like to ask Professor Michael Bria to come up. So Michael is the director of the Melbourne Energy Institute here at the University of Melbourne, and the Energy Institute facilitates the university's multidisciplinary research on technical, economic, environmental and social impacts of energy. So they do some very interesting work. So Michael, if you'd like to come up and give us your thoughts.
Well, thank you everyone, and I would like to thank the Hub first for the opportunity to speak. I'd like to thank our German guests for coming all this way. It's like this every day in Australia. We don't have clouds, great for solar, perhaps. But thank you very much for coming along. Thanks to the Hub, and thank you to Alison for coming all the way from Canberra down to beautiful warm Melbourne. I'm going to be pretty brief because I largely agree with our first two speakers in particular. In fact, I pretty well comprehensively agree. I also am very pleased to see the progress of the National Hydrogen Strategy, and I really like that you're looking at best case and worst case and in-between case scenarios, because it is a pretty uncertain future we're all aware of, particularly in hydrogen. I've been around long enough to hear all those jokes about hydrogen as I've continued to work on it throughout. But I remain fascinated. I think we all agree some practical things to do. In addition to writing more journal papers and giving universities more research, of course, that's a very practical thing to do. How about we build some mid-scale ones that we've just heard about, 10 megawatt scale units, 20 million bob each, maybe a competitive process, and maybe across different climatic zones in Australia, for example, and see how they work. I'm an experimentalist and an engineer, so I like measuring actual things and seeing how they actually perform as opposed to just modelling them, which is essential, but may not give you the right answer. I do have, generally speaking, what I'd call a tending towards optimistic view of hydrogen, which is your second most right box in your thing. And it could, of course, we could all be wrong, and as yesterday spoken about, we all get the pace wrong. And I hope we get the pace wrong and we continue to get it wrong. So I hope my optimism becomes stronger as we go. I think the opportunity to displace transport fuels, kerosene, diesel and gasoline, of course, is the biggie. Roughly speaking, I'm not sure the latest exchange rate, $30 a gigajoule Australian. I think that's about $30 a gigajoule Australian, about 20 euros. I think that's right. Is that? No, we're probably lower than that now on the exchange rate, but $30 is about $1 a litre equivalent. I think we can do that pretty well now in the best case, going downhill with a tailwind. and in the next 10 years, pretty confident of that. And once we can get well below 30, watch out. Of course, the complementarities between Germany and Australia are obvious, and they've been outlined. My own research, I work with lots of wonderful companies, including that famous German company called the Ford Motor Company. And when I visit Edson Ford Strasse in Cologne, which is a very old Ford factory, it's over 100 years old, I work with some wonderful researchers in Ford Cologne and Aachen on these very kinds of problems. How would you use a synthetic alcohol in a car engine very, very effectively? And I think that's a tremendous opportunity because it's already an elephant and it's a thirsty elephant, and therefore offtake agreements with big consumers of liquid fuels already is a tremendous opportunity. So that's me largely done. I think I'm just basically agreeing quite thoroughly with the first two speakers, but thank you for your time, and I look forward to an exciting rest of the symposium.
A lot of things falling down.
Thank you very much, Michael. So our next speaker is Andrew Dixon. So Andrew is the project manager for the the Asia Renewable Energy Hub, which I'm not going to say how big it is because I always get it wrong, because I feel like you guys just keep changing the size of it all the time. It keeps getting bigger and bigger. Anyway, it is located in an area we call the Pilbara, which is kind of the top left-hand corner of Australia. You probably flew over it on the way here. So Andrew, I'd like to invite you up to give your reflections on our theme and tell us about your project.
Good afternoon, everyone. I'm speaking from the perspective of project development. So I work for a company that started in Europe, actually. We developed wind farms mainly in Eastern Europe. We developed a 600 megawatt project in Romania in about 12, 13 years ago. Moved to Australia about 12, 13 years ago as well, and have been developing mainly wind projects on the east coast of Australia. And our bread and butter is projects between 100 and 600 megawatt wind and solar projects. And we really came to the conclusion that given the seriousness of climate change, it's not nearly enough. We need to raise the bar enormously. So noting Australia's natural advantages of excellent wind and solar resources, lots of land with not many people, many decades of successful inbound investment and international trade with energy resources, and now a very accomplished and experienced renewable project development sector, we thought, well, how can we go big? So we've been developing for 5 years a project called the Asian Renewable Energy Hub. It was actually conceived as an export project in a slightly different form. So was anyone here involved with Desertec back in the day? I'm sure some of you are. Raise hands. No? Yeah, so kind of the same vision. How do we produce in one country and then have a subsea cable to a destination country? So that's where we began. For a bunch of reasons, we moved away from that, and that was fortuitous because it means the constraint of a cable and obviously the expense and risks associated with that are lifted. So Alison mentioned that we grow and grow, so the brakes are off, and we've pivoted the project to hydrogen production. So effectively we can maximise the production capacity on our site and turn it into chemical form and then export it to the world. So our project is currently a 15 gigawatt project. We're on a site 6,500 square kilometres. We have long-term tenure, 50 plus 50 years, and therefore we have long-term access to that wind and solar resource. So yeah, officially we're 15, but we can actually go much bigger than that. So at 15 gigawatts, we can generate about 50 terawatt hours per year. Ultimate generation, 50 to 100, that sort of ballpark. We anticipate that ammonia probably represents the best carrier in the foreseeable future. That may change, obviously watching briefs on liquid hydrogen and liquid organic hydrogen carriers. We can't build the project in one hit. It's in phases over probably 10 years. And that could service different markets in different parts of the world, in different sectors, using different carriers. So we plan to start off with ammonia, obviously very keenly talking to countries now in Southeast Asia, very keen to understand the appetite from Germany. Obviously there's enormous synergy between our work and your work. Obviously we just work really well together. There are Germans involved in our project. I'm in Germany next week. There's lots of synergy, so please let's talk. It's not just all about exporting hydrochemicals, it's also about electricity into the Pilbara. A big chunk of Australia's gross domestic product is created and exported in the Pilbara in the form of liquefied natural gas and iron ore. So we can provide electricity much cheaper to the miners. 3 billion litres of diesel are imported into the Pilbara each year, 3 billion. How can we replace some of that with hydrogen that's produced in the Pilbara as well? Or how can we combine cheap electricity and cheap hydrogen and iron ore reserves to create green steel? So again, there's conversations here with some of you, I'm sure. So yeah, that's the project we're developing. We've been doing it for 5 years. We're several years away from financial close. It's a very long-term project, but that's good because each year the economics get better and better. So yeah, that's the journey we're on, and I look forward to the discussion. Thank you.
Thanks very much, Andrew. And our final speaker before we go to the panel discussion is Dr. Wolfe Peter Schill. He's an energy economist from the German, it's DIW, isn't it? Yes. Let's say DIW. His research covers renewable energy integration, energy storage, electric mobility, and other sector coupling strategies. And I just found out yesterday he is also the editor of the DIW Wochenbericht, which is a weekly newsletter that publishes articles from the Institute, which I have actually been dipping in and out of for quite some years and find very useful. If you are interested in what they're up to, I would definitely recommend it. Wolf, if we could get your thoughts, and then we are going to jump into the panel session.
Well, thank you so much. Does that work? Yeah. Thanks so much also for promoting our flagship product of DIW. But it actually is a very good product, much more than a newsletter actually. But so I'm luckier than yesterday? Yes. So much has been said, so just a few, let's say, complementary notes on green hydrogen from my side. So I see it as follows. There are potentially 2 benefits of green hydrogen in the energy transformation. And the first, that's very obvious, and we have talked much about it, it can contribute to decarbonizing other sectors than the electricity sector. And I would like to add here, decarbonize other sectors that are hard to electrify directly. And then there's the second one, which I'm kind of interested in, probably because of my déformation professionnelle. So from a power system perspective, it's interesting that hydrogen, or green hydrogen, has the potential to also bring co-benefit when it comes to renewable energy integration. And that is, on the one hand, if you just do flexible hydrogen generation and then use the hydrogen for whatever purpose later on. And that is something we've seen in the fantastic panel and the presentation earlier this morning. And even more so if you can use then hydrogen for reconversion to electricity and contribute to long-term storage. And that is something we won't need in the short and mid-term future. So many studies show we only need this when we really reach very high shares of renewables, but then that's clearly very important. And just to give you an example of these power system benefits, so I would like to give you just a very brief spotlight from current research we're doing in Germany. As you've heard, there's a lot of research on technology, but also a lot of research on energy system analysis, and we're a little part of that as well at DIW. So we are part of the BMBF Copernicus project on Power to X, and we have been carrying out some studies there. What happens if you do hydrogen generation, domestically I must say, plus distribution to fuel station, and I would like to thank the BMBF for funding this actually. And then when you go into more detail, you find out that this is not that straightforward. So there are several different supply chains for hydrogen, And if you want to hear that in more detail, I think there is a video of a jet-lag version of me talking about this for 1 hour on Tuesday here at the Melbourne Climate College, so that could be fun. But so the thing is, we compare a decentral electrolysis right at the fuel station without much storage involved, and centralized hydrogen supply chains that come with different kinds of storage. And it really depends on what you do. Is it gases, hydrogen, storage and transportation, or liquefied, or via LOHC, that is the organic hydrogen, liquid organic hydrogen carriers. So what we find, yes, this can actually lower the average electricity system costs because of cheap hydrogen storage and flexibility in scenarios with high shares of variable renewables, but not necessarily. So depending on how you do it, if you do the less flexible decentral way, then actually it doesn't have much of an effect on costs. But if you have some system that involves low-cost storage, in this example, liquid organic hydrogen carriers, then that may substantially decrease your costs. But a few words more on putting hydrogen into context. So I don't want to ruin or spoil the hydrogen party, but I want to make a few more comments. And maybe this is now more, when it comes to developing hydrogen roadmaps, as we've heard, this is probably less targeted to the supply side in Australia, but rather focused on the demand side in Germany. So I share the view that many have expressed that hydrogen has to be green in the energy transformation that is based on renewable electricity. I need this 1 minute, thanks. And if you do this, then there is clearly a kind of competition between direct electrification and hydrogen. And usually there are many applications where it's clearly the lower cost solution and obviously the solution that needs less renewables when you can go for direct electrification. Just to illustrate it a bit, to power 1 million passenger vehicles in Germany, you would need around 1 gigawatt of wind power of a decent resource, or probably the same like a decent Australian PV availability factor that gives you 1 gigawatt of PV. If you go for fuel cell electric vehicles, do you need more than double of that? That's like more than 2 gigawatts. And that doesn't even include all the losses attributed to the storage and distribution. So with a view that actually renewable electricity in a heavily carbon-constrained world is likely to remain a scarce resource, I would make the point we shouldn't maximize the use of hydrogen, but we should rather really focus on the applications where it's most useful in a carbon-constrained world, and really focus on the applications where it's clear that it's very hard or impossible to electrify directly. That is, we have already talked about high-temperature processes in industry of partly long-range transport. And this is even more true if you talk about power to liquid or e-fuels, which I realize is part of the hydrogen debate as well. So that's the point I wanted to make, and with that, I'm looking forward to the discussion. Thank you.
Thanks very much. So I'd like to ask all our panellists to come up and take a seat.
Okay.
I was told I should be on the far right.
Okay, good idea. Good
Also
idea.
wieder alles sehr gut.
We weren't sure where one started from, whether it was that end or that end.
Yeah. Okay, thank you. So, I think I'd like to start us off kind of with where we just sort of finished there, and the idea of sector coupling and the role that hydrogen plays in sector coupling. And I guess I've got a two-part question. We often, I think, and some of the discussion this morning focused on, taking spilled renewables and being able to store those or turn them into a different form of energy and so on. But I wanted to ask whether we can think about sector coupling in slightly more broad terms, more coupling, different sectors, different end use cases. but also to ask, in order to really make this happen and unlock the value from that and the carbon reductions, is this a technical problem? Is it a regulation problem? Is it an investment problem? How do we unpick that? And I don't mind who answers the question, so whoever bites first can go. Otherwise, I'm going to volunteer someone to do it.
Yeah. Well,
go for it, Falcon.
Well, I think it's none of the above. We don't have a market for it yet. And the question for me is, how do we create a market? How do we create demand for green hydrogen? And I can try to give the answer, and the answer for me is we see a global energy transition. We see that all countries have made commitments in Paris to decarbonize and to stop global warming. And in order to do that, we need to decarbonize energy production and energy carriers. And that, for me, will create an automatic demand for green energy carriers, and hydrogen is an obvious one. But now the interesting question is, when is it going to happen? And can we, as politicians, as ministries, can we accelerate the process? Because we want to accelerate the process, because we are on a way to a global energy transition, but we're not fast enough, according to all scientific research. So we want to accelerate it, but how do we do it? And we could start, for example, at the G20, and make a decision there. We could start bilaterally. We could start in the European Union, as the new Commission President more or less announced. Or we can start with regions that have a high demand for importing energy. But we need to start somewhere. And I think Germany will try to lead this process. But the interesting question is, when is the demand high enough that we actually have a market? It was very interesting to hear from Siemens that you already see a market within Australia, and that is really interesting because that could accelerate the processes in Australia very much.
Yeah, from my point of view, I mean, this is the beauty of hydrogen, that there are so many opportunities around sector coupling. We've seen in South Australia now that we're heading towards above 50% renewables, and there's a considerable amount of our renewables that's being curtailed or spilled. So, you know, a lot of energy that's being wasted. We have this fantastic gas network, which is an excellent resource for us to store that energy, direct that energy back into our gas network. And I think what I would like to see in Australia is some sort of policy around decarbonising our gas network by approximately 10%. And that will help to drive the uptake of electrolysis, build the factories that make these electrolyzers, bring the costs down on the electrolyzers, and eventually that will be commercially viable on its own. Right now it isn't. It's value destroying throwing it into the gas network, but it's also value destroying when we have to turn our solar and wind farms off and allow our coal-fired power stations to run over the top of them. So we really need to capture that wasted energy, put it into our gas network, decarbonize our gas network like we're doing with our electrical network. We have a target. The same needs to apply to our gas network. And then that will lead on to transport and industry and other areas. So that's the way I'd like to see it.
From my, sorry.
Oh, Andrew, and then Wolfe, and then Robert.
Sure. Yeah, so from my own perspective, we don't really have that much technology risk because we're really just scaling, you know, technology winners. Wind, solar, electrolyzers, whether it's PEM or alkaline. The main risk from our perspective is market risk. So obviously, you know, in our region, you know, Japan is sort of leading the aspirations for the transition, but really a number of suppliers around the world are all targeting the same small market. It's actually still quite a small market. So by 2030, the target is for 300,000 tonnes of hydrogen, not necessarily green. we could produce 3 times that in the same time frame. So it's a small market for us. So I think one of the challenges or one of the opportunities for Germany to contribute to this transition is helping create the demand, itself. So obviously there's lots of German suppliers who have the right equipment, whether it's wind, solar, electrolyzers, but really help us solve the commercials and the demand side. I think that will unlock this industry and get projects like ours away, and then others like us to follow. So yeah, that's my. Oh, in fact, I've got one interesting example of sector coupling. So we'll produce almost 10 million tonnes of green ammonia per year, in theory. We can ship that around the world with maybe our own fleet of very large gas carriers, and we can power them on green ammonia. So we can produce a carbon-free fuel and we can deliver it carbon-free. So yeah, just an interesting little tidbit.
I think people don't often think about that, the shipping as part of transport. I think when we think transport, we all think cars, because we mostly all have cars. We don't all have big ships. Yeah. Wolfe and then Robert.
So when it comes to incentivizing demand or ramping up demand and supporting the uptake of hydrogen in Germany, I would like to restate that point I tried to make, that it's, from my perspective, very important that we stimulate hydrogen demand in these very applications that are the most promising in the long term. I think it would be a bad signal if we now just, for example, green our gas network and then it goes to, for example, residential heating. And we already know there has to be really a structural change in residential heating. It has to be much to do with increasing energy efficiency and going electric wherever possible with heat pumps, just because energy efficiency is so much better. And it would be I guess it would be really a dangerous signal now if people get the impression we can green this with green synthetic fuels from Australia, because Australia is a big country, as we've heard, but we're talking about hundreds and hundreds of gigawatts. So if you only take the German demand for fuels for road transportation and heating, that would already be 1 petawatt of Australian photovoltaics. So that's a lot.
I think that also in the Germany-Australian context, as far as using our electricity to serve transport, there'll be a challenge there, because the amount of augmentation required in our electrical network to serve our vehicles for battery electric vehicles only is enormous and underestimated. Whereas these electrolyzers that are sitting in certain zones that are producing hydrogen, there is another way to move our energy around as molecules and not electrons on overhead lines, which we shouldn't underestimate the cost to augment our network. And I know that applies here in Australia. I'm not sure that that would necessarily apply in Germany. You've got a very strong network compared to ours, but don't underestimate that.
And I must correct myself, terawatt, 1 terawatt, not a petawatt. So that may have appeared to be smart, but it wasn't. So
just a few zeros.
Yeah, many things have been said, and I would agree to them. I would make 2 comments. When we think about sector coupling, then we really have to think about the systemic service that such a sector coupling does. I hear still a lot of arguments where the process efficiency is put in the front end. We heard this just in the previous argumentation, but in the end, of course, it is the system efficiency that we have to discuss, and we have to take out everything into account, and that means then maybe the sector coupling might go into different pathways. But the single one measure that drives this whole operation is, of course, forbidden in this country and was recently forbidden also in Germany, to say you have to de-incentivize using fossil fuels, and that drives the whole thing. This is one single measure that does it all, because as soon as you begin to de-incentivizing this, then automatically all these sector couplings springs off simultaneously, and you don't have to do much about this. This is not very well heard, because this is a political issue. I'm very well aware of that, here as well as in Germany, but I think there is nothing wrong with saying this is the hard negative message that one has to give.
Another thing that I'd like to point out, very good, around sector coupling is we talk about the sector coupling at the supply side, large amounts of energy, electrolyzers. But I think there's also a big opportunity around the sector coupling at the demand side. So in the homes, where we're not only serving our energy from electrical, but also from the gas grid, and we've got fuel cells. The reason why that's important is because our climate is changing, and the severe weather events that we are going to face in the future are going to turn our electrical grid off for periods of time. And now we have an opportunity with large amounts of stored energy in our gas grid to serve our energy needs at the demand side with fuel cells. This is the route that the Japanese are taking because they face these natural disasters, and they feel that this is the best way to provide energy down to the demand side in a reliable way. So don't forget that sector coupling at the end. It's not just about transport, it's also about households and industry at the
yeah, I was going to ask a question about scale, because I think pretty much everyone raised the scale question. Alan Finkel is fond of saying it's one of the three things that keep him awake at night. So, you know, we've heard some very big numbers. I am kind of pleased that you were out by a factor of 1,000 and we're not talking about a megawatt. But still, we are talking some very big numbers, and we're building from very small numbers now. Now, sometimes I think about this and think, well, Australia has done this before. You know, if you look at our LNG industry, for example, we went from 0 to being the second largest in the world. If you look at our rate of renewables build over the last couple of years, it's been absolutely enormous. In my first job, I remember we had champagne in the office when we got to 1 megawatt of solar installed in New South Wales. And last year, Australia built over 1 gigawatt of solar, and that's only over the space of 15 years. That change has happened. Yeah, I know. But a lot of time, technology does get stuck in the demonstration stage. And so how do we avoid falling into that trap with hydrogen? What are some of the ways that we can make sure we don't end up with just lots and lots of demonstrations and we never make that big leap to scale? Michael?
I'll have a little bit of a crack at that. I'm online. Well, first thing is that we can't always, because it's an uncertain thing, and we'll lay some bets and they'll turn out good, and we'll lay some bets, but they're bets, so some of them will turn out not good. And that, we get very worried about making mistakes. Unfortunately, the history of civilization, and certainly the energy system, is full of them. So why would it be any different now? And I think governments, companies are much better at dealing with risk, but governments and communities find it very hard. So we will make some mistakes. What you do, if you're sensible, is you lay some small bets, and then you very, very rigorously and coldly review the bets you've laid and see how they performed before you lay your next set of bets. And that's called portfolio management, and any good investment banker or big company does this very well. So, you know, let's just get on with it. You know, a 10 megawatt electrolyser's, let's say, fully installed, I've ordered $20 million. That's not going to break the bank if co-invested by state and federal agencies and big companies. Some of them will work, some of them won't, and we'll learn from doing that. But, you know, if you go back to the dawn of the crude oil age, I mean, there's so many extraordinary things happen. It will be learning by doing. It will be at times very incoherent, but the objective is pretty clear, and there's enormous benefits to people who are willing to take that risk. So, you go ahead. No, okay, so scale is key in the space. Like we've seen with solar and batteries, it's scale that will bring the prices down. There is no large automated factory that's building these electrolyzers and turning them out at a rate of knots. They're really being built in workshops. And I alluded to the fact that these remote area power systems, there's a little area, Cape York, northeast Australia. It's just a little horn that sticks out about the size of Italy. And it's got about 34 communities, including the Torrens Islander people, that have a need for about 1 or 2 megawatts of diesel. This is what they're running in at the moment. If we're going to replace each of those 34 communities with a hydrogen solution, solar and hydrogen, that would require in each instance, each of those 34 instances, a 6 megawatt electrolyzer. So if we're doing 20 of those a year,
that's already over 120 megawatts of electrolyzers. That is a market that's a supply and market in the same place. About $60 to $80 million of diesel is subsidized to those communities at the moment. It is the low-hanging fruit, and this is where we can start the scale. Start getting that scale right, getting the factories here, building the electrolyzers, and then starting to address projects like Andrew's.
Yeah, I would say the same thing. One has to get this thing to production scale first, because the most important problem might be that people who want to change to hydrogen would have a fear that there's not enough productivity and it can't be fast enough scaled up, and then you run quickly in a problem. And the other component that one certainly needs is also what has been said before by my neighbor, is what we have in Germany, Reallabore. So you have really to show in several instances that it is necessary to take the risk and to get started at a scale that is relevant. So this grid scale relevance is important, and that is why universities or research organizations can't do that. It has to be done in a real world environment, and this is, I think, a very critical point. If scale comes together with a variety of these application scenarios, then I think it will start off.
Great. All right, I know the delegation has to leave us, but I think that's also a good moment maybe to open to some questions from the floor. I can see, yep. Yeah, of course, yeah.
Just from us, huge appreciation for the delegation who was here, Professor Schlegel. Co-led by Professor Schlegel and Herr Lösch, and it's a living example of research and industry working together. So we wish you all the best. We understand that you now are heading for the La Trobe Kawasaki project. Please take some color pictures so that we can see the color of what you're looking at. And yeah, thank you again for joining us. Much appreciated.
That's great. Okay, questions. I saw one up the back here. And also, just because we have a slight gender imbalance on this panel, I am going to limit the number of questions that we take from blokes, and I'm going to encourage women to ask questions.
I'm happy to change my seat with a woman. So.
Okay. So maybe I think someone's got the mic over here, and then we might go to this question at the back here.
I feel shamed into offering the microphone somewhere else to it. All right, Evan Stamatier from Carbon Risk Management, and my question, I guess, is around distance. Is distance an Achilles heel? And I ask this from a position of ignorance. Are the Germans not also in I guess, negotiations with Algerians about Saharan green hydrogen and sending it via a pipeline to Europe? And I know the International Maritime Organization has a goal to decarbonise, I guess it's 50% by 2050 based on 2000 levels to cut gross greenhouse gas emissions. And the commentary I hear is that that's going to be hard to reach. So is the emissions component of shipping also going to work against this arrangement that we're talking about?
I mean, obviously for transmission lines, for pipelines, distance is very important. Shipping, particularly with a zero carbon fuel, is really not a big deal. So, we are literally looking at global markets. I mean, our main focus has been the Southeast Asian region, but it's relatively trivial to ship further. It's not a problem for us. And obviously we're doing very large ships, 60 to 80,000 tons. And the energy consumed to get it to market is really not that big a deal, from our perspective anyway.
I guess indirectly Germany could benefit from such developments here anyway. So from an economic point of view, even if not a single hydrogen molecule from Australia ever reaches Germany, if the whole market develops, then obviously, and costs go down, then that may benefit Germans sourcing their hydrogen somewhere, the bit of hydrogen we need, I must say, sourcing that from somewhere nearer. So.
I actually looked at this the other day for just Australia versus Qatar going to Japan. And it's interesting because when you're Australian, you tend to think you're a long way from everywhere, but actually we're closer to most parts of Asia than most other people are. But the other thing that is interesting is about where the boat has to go. A boat that is coming from the Middle East has to go through the Straits of Hormuz. and to get to the Asian market, it has to go through the Straits of Malacca. And so even if it's not just the distance, it's where you have to sail and what are the geopolitical conditions around where you have to sail as well.
Also, obviously, geopolitical risk in the production company. I mean, my understanding of Desertec is that one of the key reasons that it ultimately didn't proceed was geopolitical risk in Northern Africa. So one of the attractions of Australia and Northern Australia is very low geopolitical risk, and decades of successful experience at significant inbound investment in infrastructure projects and then trade of the products. So again, I think Australia is a very safe pair of hands, very geographically stable, geologically stable, and nations like Japan who are thinking long-term energy security definitely consider that as part of their decision on where they purchase their energy. Yep.
Should we go to the question up the back there?
Hi, Amanda Carl from The Next Economy. I'm glad we're starting to talk about politics because it's been something that's kind of tried to come up a few times today. It's around the social and political dimensions around technology and what's appropriate in terms of technology. So just to give you an example, I want to challenge the point about Cape York, because I was having discussions, won't say with which government, well actually it's obvious if we're talking about Cape York, but not just like Queensland communities, about remote Aboriginal communities dependent on diesel and the potential around small-scale renewable energy, and it just seemed a no-brainer and a very easy political win. It still hasn't happened with affordable, proven, cheap technology. So I just want to, and there was a question earlier around why not heat pumps. So I just want to raise that and put a question to you, Alison, then around government's role. Are we just leaving this up to the market to see, as we experiment, which technology takes and that's it? What is government's role and responsibility in shaping and driving which ones get up when there are social and political dimensions to this, not just technological and economic considerations?
Sure. Would anyone on the panel like to comment before I jump into that question?
Yep, you go.
Well, interesting point on Cape York and the challenges around that. And believe it or not, the challenges are that there are concerns that the jobs in place to drive that diesel from 1,000 kilometres away to these remote communities potentially would be lost. And that seems to be a big issue as it relates to that and the unions, as I understand it. I'm not an expert on it, but this concept gives those communities the opportunity to learn in the STEM area, be able to not receive diesel on a silver platter as a subsidy, but now to start to produce their own fuels on site, linked to the IPPs or providers of the technology. But there's also great value in oxygen, for instance, and the opportunity to do aquafarming and to clean up their waste water using oxygen. So there are all sorts of value streams out of this. And what we need to do is convince government, and this is the arena pathway to getting a pilot project up and showing that it can be done, and then just repeating the same for the other communities. So that's what I'm hoping will result out of that. But there are also South Australia, lots of these remote communities that could do the same, and I think everywhere else in the country.
Can I respond to that? Again, it's like who gets to decide that, and which jobs and whose jobs? And to me, the advantages and the benefits of community-owned renewable energy for the local communities and the jobs that are created there and the money staying in that community, how does that get weighed up against the diesel jobs, which are probably, make this simplistic, white jobs versus black jobs? So that's the complexity of what we're talking about. I work in regional communities, and I just want a bit more of that discussion in these rooms. That's a challenge for the next time this group gets together, I guess.
And
who gets to decide that?
We're having the community lead this project, so it has to be something that they want, and so that engagement is with a leader a stakeholder in the community space. So they're driving that process. Will only come in when they've solved that problem.
From my own perspective, as renewable energy is extending north, it's moving on to the Indigenous estate. So it's land over which Indigenous communities who've been living there for 50, 60, 70,000 years, they have actual rights over that land, to determined exclusive native title rights. Our project is on land over which a community has determined exclusive native title. So one of the key agreements that we're finalising is with this community. So it'll be a landmark agreement. It'll be, you know, a transformative agreement for them, and hopefully a precedent that other projects that follow us can use as a precedent. So yeah, I think, our project coming in and engaging with this community and benefiting the community will help weave them into the economic fabric of our nation, which is something that's been missing, you know, until this point. So renewable energy has a social dimension to it that's very powerful, and it certainly motivates us.
Although one of the concerns I would say with that community, which I think is only about 200 people, is the royalties that they receive from it are enormous. And, you know, how do they, as a community, handle that?
So that's all about really governance. So that's what we're working through now. We don't want to come in and create harm, you know, through dumping money onto a small community. So yeah, they're scared of it a little bit, and it's about investing money instead of just going for the sugar hit in the short term, investing it in their education, investing in capability, in infrastructure. So yeah, it's a good problem to have.
I think it's me now. Gabriel Sartori from Hydromine. I actually have a question either to the person from Siemens, Warner, or to Andrew. I would like to understand how complex this technology is for the community up there in Cape York, because I've done a pretty big APEC project in Indonesia, and I just learned that local communities have difficulties with really complex technologies. And what I learned is really it needs to be very simple, and you know, they need to be able to maintain the system themselves, and not complicated with spare parts, difficult to get those spare parts, because otherwise, I mean, the whole thing is going to be in the dark. So I was just wondering, how complex is that actually, and is it easy for the community to operate it and maintain it?
Very good question, and I'll say straight up front that these electrolyzers and these fuel cells are simpler than a diesel engine. They're essentially passive blocks that sit there. They have no moving parts whatsoever other than the water purification for bringing pure water into the systems and cooling on the fuel cell side. So the operations and maintenance really relate to the water purification. And every now and then you unplug a cell and replace it with a new one. So it's plug and play, and we're talking once every 5 to 10 years. The electrolyzers will last 10, 15 years without having to touch them. The fuel cells, they will be replenished block by block every 5 years. So very, very simple technology. And when you put the whole lot together you've got your storage of hydrogen, you've got your storage of water, you've got your electrolyzer and your fuel cell. It's a closed loop, so the water that comes out of the fuel cell goes back into the electrolyzer. You lose about 25% of the water, so water is important. But that whole thing is controlled by an autonomous control system. So very, very simple technology. It's been around for decades, just about all getting to work together.
Time for one more question. I saw Ken Baldwin had his hand up. Oh, there's one up. Actually, Ken, do you mind if we take that one and up the back? Because you've got a whole panel coming up. You can talk as long as you like. There, you can do that.
Thank you. Ursula Fuentes, Murdoch University and Climate Analytics Australia, based in Perth, Western Australia. My question is mainly to Andrew. Going back to the original idea that you had with the subseabed connection to Indonesia, I believe, and you also referred to your continuous interest in Southeast Asia. And now that you're moving away more towards hydrogen, and I know the discussion has been a lot when you discuss hydrogen export opportunities, and the reports that have been done have been focusing very much on countries like Japan, Korea, and not that much on Southeast Asian countries. However, Southeast Asia, of course, is the region that is the fastest growing region in the world, with a huge coal pipeline that risks basically busting the achievability of the Paris Agreement. So decarbonizing Southeast Asia is a very important challenge, and I know it's also a strong interest of the German government and other European governments to support Southeast Asia to a transition to sustainable energy. So I'd be interested in through your work into this project, how you see also the role of hydrogen exports to Southeast Asia, even though that might take away some of this hydrogen, or a lot, and it might never reach Germany. For these countries, because of course the distance is very short, and this huge growth is not only electricity demand, but also industry and transport. Thanks.
So obviously we're mainly talking to Japan, Korea and Singapore, mostly because they're the most developed in progressing their thinking and their plans. And again, I mentioned that there's mainly market risk. So we need to focus on the markets that will move first, but of course we will sell to anyone. Interestingly, in Japan, their initial thinking of green ammonia use is co-firing in coal-fired power stations, which obviously as a renewable guy I'm initially uncomfortable with, but they've demonstrated at scale 20% co-firing of green ammonia in a coal-fired plant with minimal modifications to the burners. So they've calculated that if all 90 coal-fired power stations in Japan co-fired at 20%, the national emissions of Japan would drop 5.5%. So that's a really significant step change. So obviously other countries, Indonesia, other neighbours who burn coal, in theory could start off there as well. In the meantime, as gas turbines scale that can burn ammonia, that really is the holy grail for us, I think. So thermal power production using ammonia as a carbon-free fuel source. So yeah, our thinking is not just Japan, Korea, Singapore. It's really much broader than that, but you've got to start somewhere. So again, I mean, Indonesia, our first plan was to sell electrons. It'd be great if we could sell green ammonia to them to start off as the Japanese may, co-firing in coal-fired power stations, then gas turbines, and then other applications as well. So yeah, it's an evolving story. It's changing day by day. Yeah.
Well, we are almost out of time. In fact, we're well out of time. I had one very final question for everyone on the panel, and we can do a one-sentence answer if you like. When I took on the job of doing the National Hydrogen Strategy for Australia, I did a quick check back through the files to see whether we'd done anything before, and lo and behold, I found we did a National Hydrogen Strategy in 2008, which said it was all about using fuel. It ended up saying, it's all going to be fuel cells for electricity in Australia, and Australia should be aiming to be a world leader in fuel cell technology by 2020. So we better get onto it, guys. But I think the thing that I took away from that and from other experiences I've had as a public servant is that you are almost certainly turn out to be wrong on the micro level, but often right on the macro level. So what would your advice be to Falk and myself as we go together, putting together roadmaps and strategies and so on, to make sure that we end up right on the macro level, if not right on the micro level as well? If we come back to our strategy in 10 years' time, are we going to laugh at it, or are we going to think, yeah, we pretty much got that right? Start with Michael, because I think Michael remembers the previous strategy.
By Bruce Godfrey, I think, wasn't it?
Oh, yeah.
So resilient approach and robust approach to policy development, as you might do to a future energy system. Of course we'll be wrong and right on some things, and there'll be all sorts of expected, unexpected things, intended, unintended consequences. But I defer to policymakers, but there are good ways to design policies that drive things in the right direction, even if they surprise en route.
So, I mean, a good question. I don't know that we have an alternative pathway other than the hydrogen pathway, because if we're going to take large amounts of renewables, fluctuating renewables, into a grid that's spread over such an enormous country, we're going to have enormous amounts of storage. So, electrolysis is going to play a role. Is it going to be PEM or alkaline? I think it's PEM because it's fluctuating. So I definitely think that we're on the right pathway. Hydrogen's a mainstream discussion, and it's all because of renewables. If it wasn't for renewables, it would be a mute topic.
Yeah. Andrew?
I guess from my perspective, it's not just an energy debate, it's an industry development debate and an economic development debate. So, I mean, this is, obviously in Australia, energy politics is toxic, it's very fraught. But there are so many opportunities through renewables, particularly when you can bottle it as a chemical and ship it. people can relate to it, like LNG. It sort of takes the heat out of the politics and the ideology. And there are huge opportunities for those who can produce and produce projects, produce the technologies. And I think we need to view it in that light. So, really focus on the economic opportunities rather than just getting mired into the sort of the energy, politics of it.
When it comes to missing industry policy targets, Germans are also very good at that. So by 2020, we wanted to be the lead market for battery electric mobility. So that didn't work out, actually, but we're on the way. And when it comes to the roadmap, so for the German side, it's a bit boring, but I would reiterate, just focus on the right applications. And then we won't regret it so much, I guess, in 10 years.
Well, I'd like to thank everybody for a very interesting discussion. Falk, did you want to add anything before we close? Or
No, I wrote
you
down
the
everything
things
that they
do?
said.
I had wrote them down too.
And now I just need to put it in the
Yeah,
strategy.
it's easy, right?
So thanks for that.
Yeah. So please thank all of our panelists today for a very interesting discussion.
I guess when it comes to Indonesia.
Thank you so much, Alison. That was a fantastic story, and it was a story also about one terrific export from Australia that already reached Germany. What is it? The national hydrogen strategy.
The problem is they're not going to be a repeat customer.
And in 10 years' time, we'll do another one.
It's certainly not the only great export that Australia has to offer. For example, smart meters is another one, etc. But in order to help Alison and Falk on the macro level and to be right on the macro level, we have now for the break for you, again, a little voting here. And the question is hydrogen in Australia mainly a story about direct exports? A story about direct exports plus indirect exports, so you use the hydrogen here on shore for energy-intensive goods, like what we are going to hear also in the next session? Or is it a story about all three, direct exports, indirect exports, and domestic use? Obviously, it's a mixture of all three, but what is the focus? What is the main story here? So please help Alison and Falk in their macro level thinking, and thank you very much for this fantastic session. We are going to meet here back in 15 minutes for our last session that wraps everything up, an additional great opportunity for Australia on energy-intensive industries led by Professor Ken Baldwin from ANU. So see you all soon. Enjoy your coffee break. Thank you.